So if I look at this is an exponential equation. Anytime we have an equation, your goal is to say what value of x is going to make this statement true. That is what you look for when you have an actual equation. So anytime you have an exponential equation, your goal is to get like bases. That's the goal. Anytime you have or try to solve an exponential equation, that's your go-to method. That's the first thing that you want to try to do is get those like bases. Now, for this particular problem, I have a 1/3. So because I want to get something that's a like base, the same thing with the problems that we just did, where you have that base that's a fraction. In order to move that 3 to the top, you have to make it a negative exponent. So I'm going to rewrite this as 3 to the negative x is equal to 81. And that now makes a solid base that we're looking at and is easier to find. So now I have to say, I've got this 3 as a base over here to the left. So I want to figure out what is my base to the right. And we can also look at that in terms of 3. So 3 to what power is going to be 81? To the 4th, good. So 3 to the 4th power is going to get me 81. My goal is to get like bases. And the reason for that is this is an equal sign. So whatever is on the left is equal to whatever's on the right. And if the bases are equal, then the exponents have to also be equal. So as soon as you get your like bases, now you can set those exponents equal to each other and solve for x. You can't solve for anything that's up in the exponent. So you have to figure out how to get it out of the exponent so you can work with it. And that's what you do. Now to solve for x, I'm going to divide both sides by a -1. And x is now equal to a -4. You can always check if you want to. It's not required. But you can always check. And you have 1/3 to the -4 power is equal to 81. Well, to make my exponent positive, I now have 3 to the 4th is equal to 81. And we all know that to be true. Pretty cool. Let's try another one. For this problem, we want to get like bases, but notice there's a lot more going on in the exponent. So we still want to get like bases because anytime you have a variable in the exponent, that is an exponential, and that's your go-to method. We're going to learn later that there's another method to use, but your go-to method is anytime you have like bases, you want to get the same. Or pardon me, anytime you have a variable in the exponent, you want to get those like bases. So let's do it right now. Anytime you're looking for your like bases, you always want to have the smaller number. Is there any possible way here with this 2 that I can make 8 with a base of 2? 2 cubed. So now I can write this as a base here of 2 to the x plus 4 is equal to 2 cubed to the x minus 6. Remember, power to a power you multiply. So we have this is a like base of 2, and this 8 is now represented as 2 to the 3rd power because those are also equivalent. And power to a power you multiply. So I now have like bases, which is what we wanted, so set those exponents equal to each other, and then it's just a nice little linear equation that you can solve. So distribute it and work it out. X plus 4 is now equal to a 3x minus 18. I'm going to subtract x from both sides just to collect my x's first. Then I'm going to add my 18. So now 22 is equal to 2x. When you divide both sides by 2, x is now 11. You are welcome to check. That's completely up to you, but it is not required. So that's your call. If that's something that you want to do, you can. Cool. Let's try another one. Now at this point, we're going to pause your video. You try to work this one out, and then turn your video back on and we'll work it together and see how you did. All right, so go ahead and hit pause. Okay, now we're back. Let's see how you did. For this one, I'm going to have 9 is the same thing as 3 squared. So I have 3 to the x plus 1 is equal to 3 squared to the x minus 3. As soon as I have my like bases, then I set my exponents equal and solve. So x plus 1 is now equal to a 2x minus 6. I'm going to subtract my x from both sides. 1 is now equal to x minus 6. When we add 6, x is equal to 7. Is that what you got? Awesome. Great job, great job.